In this video we will show you how OptiLayer solves a design problem of Beamsplitter. This Beamsplitter separates the incident beam into two parts, reflected beam and transmitted beam. The ratio between these beams are, for the one design transmittance is 30% and reflectance is 70%. And for the second design transmittance is 70% and reflectance is 30%. The operating spectral range is from 400 to 800 nanometers. Layer materials have refractive indices 2.35 for high-index material and 1.45 for low-index material. The substrate has refractive index 1.52. Now we demonstrate you how OptiLayer deal with these two problems. First of all, we specify a target for the first design. We set transmittance values equal to 30% and reflectance values equal to 70%. The spectral points are from 400 to 800 nanometers with the step of 5 nanometers. Then we load this target, substrate and layer materials, with refractive indices 2.35 for H-index material and 1.45 for low-index material. Finally, we load starting design, which contain one layer and has physical thickness 600 nanometers. To obtain a good solution, we use for this task needle optimization auto option. The result we can see on the screen. But here we have one thin layer. In history window we can see a previous design, which have 12 layers without thin layers. We choose it, and we can see its structure. The thinnest layer is about 20 nanometers. For second task we make all the steps, as I explained before. First of all, we specify a target for the second design. We set transmittance values equal to 70% and reflectance values equal to 30%. The spectral points are from 400 to 800 nanometers with the step of 5 nanometers. Then we load this target. The substrate and layer materials are already loaded, so we change only starting design. Design contain one layer with the physical thickness about 200 nanometers. Finally, we load this design and start needle optimization auto. The result we can see on the screen. The design has 15 layers. But here we have some thin layers. To reduce them we use thin layer removal option. The stop criterion is that layers must be thicker than 10 nanometers. After that we obtained a 5 layers coating. We can see its structure. The thinnest layer is about 12 nanometers.